Alrighty, let's try out this exciting new print feature in C++23. So I've got my compiler set up. I think so, at least. Let's give it a try. And we don't have the library here. So, I'm going to save you the deep dive, but basically we need a compiler that has the C++23 libraries and specifically print available, and then we can use some of these cool new functions in my C++ series, as well as if you're using other different languages that rely on G++, I'm going to show you how to build GCC and G++ from source here. Alrighty, so let's go ahead and get into it. So welcome folks, welcome to my channel, and if you followed along, we have done some GCC from source videos before, but again, I want to show you the latest version, and I want to go ahead and walk you through the different options. So if you have a few minutes to spare, I'll go ahead and help you understand stuff so that you don't just copy and paste it from Stack Overflow and cross your fingers. You'll actually know how to install and fix your dependencies. So anyways, with that said, let's go ahead and go back to our terminal here. And what I'm going to go ahead and do here is I'll get rid of this. This will be our goal to see if we can compile that program here. Let's just go ahead and shrink this down here. And what I'd ask you to do is open up in your terminal and navigate to download. So something like this where you can download the GCC source code. That's what we're going to be doing and building from source. Now, you will need to have some experience with your package manager. I'm going to be using apt and apt-get on Ubuntu. If you're using Pacman, they should be pretty similar, or Yum as a package manager, that also should be relatively similar. Okay, so if you're on like Windows subsystem for Linux, this will also be fine to follow along with as well. Alrighty, so anyways, let's get into it. Again, C++ series, which you're maybe interested in for following this, but let's go ahead and check out GCC. And I'm just going to go ahead and take us, since we're interested in GCC 14 here, to the installation here. Okay, so let's go ahead and check that out. Now, there are a few prerequisites that we're going to want to pay attention to. Namely, we need a C++ compiler and at least version 4.833 as specified here. So if you want to go ahead and check that out here, just do G++ version. I've got version 11. Most of you in the last half decade or even maybe decade have at least version 4.8 available on your operating system. Okay, so if you're using an older system or Raspberry Pi or something, maybe pay a little bit more attention to that as far as getting set up here. Now, the next thing that we're going to have to do here is make sure that we have the compiler and some of the other tools like make and configure and these sorts of things here. So you could do sudo apt install build essential. I'll make sure I type it out correctly. And that's going to download a bunch of, again, essential tools that are needed on the system here. Now, I've already got it for my Ubuntu system here. So it looks like we are good to go, okay? But just make sure that you have that. And I will copy and paste these into the description below so that you can go ahead and check those out. But again, we want to understand what's going on here. So let's look at our other prerequisites that we've got to keep track of here. Python, and again, if you do Python, I recommend the Python 3-dev so that you have the dev libraries. This we don't care about because we're not doing Ada or D or anything else today here, or Modula 2. And you might need the bin utils. Okay, so if you don't have those, you can do apt cache search bin utils and find the version for your architecture that you need. That'll give you the assemblers and so on that you need. Usually just typing in bin utils will bring you in the right thing, but we probably want something like, let's see, bin utils for, this is what I would install for the bin utils, okay, if you don't have them. Anyways, and then you might have a few other things like gzip and so on. So let's keep scrolling down here. These libraries here, these support libraries are necessary. So necessary to build GCC, necessary to build GCC, necessary to build GCC, necessary to build GCC, okay? And these are like precision libraries, integer libraries, compression libraries, and so on, Python 3 modules, and so on. So let's go ahead and just show you, how to find those. So again, apt cache search, usually prefix with lib, and then like the abbreviation, GMP, and usually you want the dev version, okay? So that's what you find. You can install the latest one. And if you have issues, usually installing just the dev will bring in the latest version as well. So again, a few different things you can try. So let's go ahead and do that here. Let's do sudo apt get install libgmp-dev, for instance. Looks like I already have it. And you can add these together here, so you don't have to keep typing it. Again, just a little tip here. So libmpfr-dev, that's this one here. So again, looks like I already have it. We'll do MPC. Again, I'm just appending these here. Libmpc-dev. Looks like I have it. Libisl-dev. It looks like I don't have this one here. I don't know if I necessarily need to upgrade it, though. Let's see. If it gives us any issues, I'll know to go back and install that. But that is the basic idea here, okay? Let me actually search that one here. Anytime you run into a snap, let's do libisl-dev. Manipulating sets and relations of integer point bounded by linear constraints. Okay, it sounds interesting. Let's just install it because we want to have the full set here of things here that I can give you in the copy and paste here. And let's do libzstd-dev as well. Okay, which I already have. Okay. The other little hint that I'll give you is sometimes folks will put a -y at the end, which means just say yes, install everything so you don't have to keep getting prompt. Or if you're in a scripted environment where you just want to hand off a script to someone, then it'll just accept and download all these libraries without somebody having to be there in case this takes hours and hours and hours. Okay. So now that we have our prerequisites, or we should have most of our prerequisites, let's go down to the downloading the source. And there's a few different ways you can do this. You can find a git mir or different things here. I'm just going to take you to ftp.gnu.org. And the easiest thing to do there is then to go to GNU, make this a little bit bigger for you, search GCC, and then we want to search version 14.1, which will take us to the bottom here. And then we want the 153 megabyte one, right? The largest one, as you might have guessed here with the source. And let's go ahead and just copy that link address, okay? Because again, we're going to do things from the command line because you might want to script these types of things here. And the tool that I'm going to use here is wget. And let's go ahead and download this tar file. So it should just take a few moments here, and I'll go ahead and leave the video for a minute, and we'll let this continue. Okay, and looks like we finished up there. So we can now cd into our, well, let's see. Well, we've downloaded the file here. What can we cd into? Well, we've got to actually extract this file here. So tar, which is a tool that you can use to work with archiving, and we want to use options like X to extract the file. Let's see if we have some X extracts or gets from the file. I also want to put in, let's see, if I search with /-f here, and then next. Let's see if I can find the actual option here that I want. I'm just hitting N to move through, and that this is a file or an archive format, okay? So that's where you're going to see things like tar-xf. I can put those flags together. And then the file that I want to extract, which is the GCC file here. Now this is going to break it out into, by default, this directory here. There's other things you can do with tar if you want to rename it, but this is going to be fine or perfect for our purposes. So let's go ahead and extract out that file here, which just took a moment here. Move into this directory, and now we have some GCC stuff set up here. Now I want to go ahead and keep our directions open because we're now on the configuration stage here, okay? What do I mean by that? Well, if I do an ls here, you're going to see a bunch of different things in the GCC directory here. So most Unix projects, you'll find some standardized tools, things like configure and make and so on, that are super useful for building software across different machines and different configurations. So that's why we're in the configuration step. We've got this tool here called configure. Looks like I don't have a manual page here for it, but let's see if I can run configure --h or sometimes -h for help. Let's see if it gives us any help here. No help, we could just Google around here. But this is the tool that we're going to use. Let's go ahead to the GCC documentation. And basically what this tool is, and like most GNU software, we need to configure it and figure out how to build. So there's different things we could do, like what directory do you want to build things in, and when we're building a compiler, how we want to set up that particular compiler. So the first thing that we really care about is like the host, build, and target. So host, let's see here. These are defined here. So the build machine is what we're using. The host machine is a system where I want to run the compiler. Okay, so something like Linux. And the target machine is a system for which you want the compiler to generate code. So maybe I want it to generate code for a Mac or something. Okay, so I can specify like an ARM machine or something. For me, I want to do development. So that means the host, build, and target are likely the same thing because I want to use the machine that I'm currently on to build for the currently machine I'm on that can generate code for the current machine that I'm on. Okay, so hopefully that makes sense here. So those are going to be the things that we want to configure. There are some other things that are useful to configure. And here are some of the different types here. The prefix here, for instance, is going to be useful for like the install directory, so we can actually find our compiler when we want to build it. Let's see what else is in here. So I'm going to go ahead and say that's useful. Let's see, with local prefix, GCC major version. Sometimes, actually, let me go back here. I want to actually specify the program suffix here, so that it generates the compiler with like GCC 3.1, because you might end up with a bunch of other versions, so that's actually really important. The prefix, again, you could change if you wanted to say like mics, or like if you're doing like a custom build or modifying it for your company, that might be also useful. Let's see what else is going to be useful for us here. If you don't have these, otherwise you get the defaults here. Let's go ahead. These are things like doing like different linkers and so on. I don't know if I need things like, let's see, these are all the different things. Multilib, let's see, specify that multiple target libraries to support different target variants. Calling conventions should not be built. Yeah, I'm going to disable this. I don't think I need this for now. You might need this if you're building the compiler, for instance, to because you want to develop software for the Dreamcast or the PlayStation or something, right? So I'm just going to get rid of that to speed up our build a little bit, because that is one of the reasons that you want to change things. There's other things like languages. Let's see, I think it's dash languages, enable languages. We're just going to do C and C++, but again, if you want D or Fortran or other languages, you can set some of those different settings here. Let's see, there's another one, enable checking. Let's see here. Yeah, we could add some like error checking if we want. Yeah, it's sort of up to you if you want to do this. Again, you know, that might be another useful option for you. So anyways, let's go ahead and try this. So let's do configure. And again, just from within this directory here. The version, I'm going to do the build, x86. This one actually might cheat and copy and paste in because we already set it up and I don't want to waste us any time here. But this is what the command is going to look like here. Let's go ahead and have it here. So again, the build, this is the machine it's building on, the host, you know, my machine, or where we're going to be building things, the target architecture. So you can see, I mean, these flags are all the same thing here. I'll show you a little trick here. Let me just split this window again here. There are useful tools like uname, for instance. If you don't know, and you can get like some facts about your like machine and the architecture and these types of things if you really don't know. There are ways to query these things on the command line. So, you know, printing system information. So anyway, just a little thing there. So let's run configure here. And basically this is going to do a bunch of different checks to make sure we have all the dependencies that we need. And if it works, it'll generate a make file. Okay. So if we look at when that make file was generated, we should see it's a little bit later. I am recording this on July 3rd than our other things, right? So that's what it made from configure. If you look at that make file, just in case you're curious, basically it's going to have set up some of the different things like the build machine. It should have like the host and the OS and all these things that we configured here. What our prefix was, okay, if you caught that where we're building here. Okay, so that's the basic idea, and now we just need to run make. Now this process might take a little while here. You'll run make. I like doing -j and then specifying the threads. Maybe 32, for instance, would be reasonable. Depending on your machine, maybe 8. If your build fails, you can try just make, which will do a single threaded build, which might be necessary in case something gets messed up with the dependencies. So just try that as a fallback. I'm going to try -j 32 because I've got a machine here, and I'm going to go ahead and kick this off and leave you for a moment as this finishes. Okay, so not too bad, about 25 minutes or so on my system, and hopefully you had time to grab a coffee or relax a little bit. The last thing that we're going to do is a sudo make install, and basically what that's going to do is set up, once you type in your password, the paths for your GCC or G++ compiler or whatever languages that you otherwise installed. So that's what all this is doing, setting up some different paths, so we'll be able to type out GCC here. All right, and the other thing to pay attention to here is this particular line here. If you're looking for your GCC compiler here, now this is showing you where the libraries have been installed to on your system now, so from your bin install here. But this is where you'll find your bin and your C++ compiler. Something that folks do to simplify things, so again, if we want to check which version we have here, we'll see that we still have version 14 here. So let me show you first that we do have this installed, again following this where the libraries and the binaries have also been installed in user local. This will be GCC 14. I want to go in bin and G++ here. And now if I run version on that one, we will successfully see that we have version 14. So congratulations, at this point, you're all set here. So now we can actually try running this program here, and then we'll figure out how to make it just a little bit more convenient here for building. So let's go ahead here. Let's go ahead and just copy, well, we'll just type it out here, no problem. User local GCC 14-1, the bin, G++ compiler. Let's see, we called this program main-o prog here. Still getting that little issue here, but remember we got to set our compiler flag to C++23, and this time it's compiling, and this time it's running. So we have hello Mike here, and we can also use some of our other C++ functions here, like print line, just to make that a little bit nicer, recompile, rebuild, and we now have a C++23 feature with the latest compiler here. Okay, so the last thing that I'll go ahead and show you how to do here, and I'm going to go ahead and copy this here, is we can paste in basically a way to update what our default path is for G++. You know, so there's a couple different ways that we could do this, I guess, with just the version here. So I'm fine with this here. Oh, let me make sure I set the right path here. Let's see, local GCC 14, let's see, 1.0, there we go. And I think that'll do the trick here. Oops, let's find it. Let's see here, user, local GCC, bin, G++, 14.1. Okay, so that looks like it worked there. Now let's try G++ version, and that is giving us 14. You might also want to do this for GCC as well, if you're, again, just trying to use the latest C compiler. So let's go ahead and just change these to GCC and make sure everything is otherwise kept up to date here. So that should also be set up here. Okay, so it looks like we're good to go here in that case. All right, so hopefully you're now excited about doing some C++23 development or C23 development or whatever you know the latest standard is, and you know and understand how to configure a few different things about GCC. All right, folks, so with that said, hopefully you enjoyed that lesson. Hopefully you enjoyed building GCC once again from source. Always enjoy doing these videos because I always learn something as well, and it's very, very useful and important lesson to be able to build software from scratch, to understand how stuff's made under the hood, and it gives you the freedom, once you know how to build it from source, to modify things and so on. Anyways, folks, thanks for your time and attention. I'll look forward to seeing you the next time that we build GCC.